Good afternoon, everyone. Just a quick mic check. Everybody can hear me in the back okay? Awesome, cool. A lot of familiar faces, so welcome. Thanks for attending our session on Ubuntu snapshots and how Microsoft Azure is integrated with it. I'm David Duffey from Microsoft Azure, and I'm here today with my dev leads from both Canonical and Microsoft that's put it all together. First, I wanted to give you a quick overview of Azure's safe deployment practices, why it matters, and a hackathon project that we worked on. Then Colin Watson is going to talk about Ubuntu's new snapshot service, which we're leveraging today. Then Ye Wang from Azure Kubernetes Service and Koshy John from Azure Guest Patching Services is going to talk about how they've integrated with that service. And we will leave time at the end for Q&A. And I'd just like to address the elephant in the room for a second, that being at Canonical for 6 years and here as a Microsoft employee, it's like really an honor to be here. And I know my colleagues feel the same way. And to show that I'm still Linux through and through, this is my Halloween costume for this year. But first, because this is an Ubuntu Summit, I wanted to share with you an overview of a term and a framework that our offices of the CTO put together called Safe Deployment Practices, or SDP for short. And SDP is how we approach our Azure DevOps to both minimize and mitigate unforeseen issues. And our SDP guide states that sometimes the release doesn't live up to expectations. Despite using best practices and passing all quality gates, there are occasionally issues that cause production deployments and unforeseen problems for our users. And if we follow the SDP process, not only do we increase the speed and quality of our production releases, but we improve the experience for both our users and the engineers that provide live production support as well. A few of the guiding principles are: be consistent, that as you do a rollout and scale, that there's consistency to it, that quality signals matter so that you can be proactive, reduce the blast radius, and recover quickly. And deployment should require zero downtime for our users and happen during business hours for our developers. And both Ye and Koshy are going to dive a little bit deeper in this, but you can learn more about SDP by searching Microsoft Learn for safe deployment practices. Which brings me to why are safe deployment practices important? Well, we learned last year when we had an outage that affected several of our services, including Azure Kubernetes Service, and we woke up to this news. And our services were using unattended upgrades, and there was a very specific sequence of events over a very specific order and time frame that caused this issue and impact. And to dive a little bit deeper, what happened was a security update to Open VM tools that caused UDEV to lose information about Microsoft's accelerated network adapters. And it didn't cause any immediate impact, but a few days later, a security update to systemd caused a network restart. Any nodes that applied that patch when the network restarted, because the adapter was not associated with an interface, those nodes lost networking. A simple reboot would fix it, or there were manual mitigations. And I also want to say thank you to Canonical for support and getting a quick fix out to our users as well. And the fundamental problem is that we didn't have the consistency when we were doing the rollouts. And even for services that were using Azure Guest Patching Services, the best thing that we could do is we could detect that there was a failure and then stop the rollout. But there was no way for us to continue doing the rollout with some good node working, or at least there was no easy way to do that. And this issue, coincidentally, was just a few weeks before Microsoft's global internal hackathon. So I put together a proposal that borrowed from some concepts that we do with Windows and SDP, called for collaboration, and both Ye and Koshy were the tech leads and top contributors to this project. And what we did was we added published date information to every package in a repository. So on the left-hand side here, we have OpenVM tools, 2 different versions of OpenVM tools. We added the published date information in yellow. And on the right here, you can see systemd, where we did the same thing. And then we verified that the existing package managers like apt still worked with this additional metadata, which they did. And then we modified apt to include a new argument, exclude after, where you could pass a date and time, and it would update all the packages up to that particular date and time. Then we reran that sequence of events that took us down, but because we could specify a date, all the nodes didn't get the latest systemd package update, and we were able to complete that rollout from beginning to end. So we actually took first place in the executive-sponsored Hack for Quality. We got the highest rankings across all judged categories, including inclusion and inspiration. So as you can imagine, we were like really flying high, and we reached out to Colin to share our results. And that's when Colin shared with us a service that Canonical was working on. We started jointly collaborating with, and the service that he's going to talk about is what we're actually leveraging today. So Colin.
All right, good afternoon. Hope you've all enjoyed the summit and that you've seen a bit of this beautiful city. Thanks, David, for the introduction. I'm Colin Watson. I've been Launchpad's architect for the last few years. Before I start, personal note, I was one of this small and disturbingly young and frankly rather scruffy group that Mark pulled together to build Ubuntu back in 2004. So it's been quite an amazing journey. After nearly 20 years at Canonical, I've decided I'm going to move on at the end of this year and try something else. So this is kind of my swan song, but I do intend to stay active in the Ubuntu community. So, as David said, this is where the problems that Microsoft was seeing on Azure started to overlap with plans that we'd had for a while in the Launchpad team at Canonical. If you're not familiar with Launchpad, it's the development platform that Canonical built for Ubuntu. Among other things, it's responsible for taking changes that developers upload to Ubuntu, building them for all our architectures, and publishing them in the form of an archive that tools such as apt can use. First, I just want to give a bit of a history lesson and on how we got here. So back in the very old days, and this was slightly before my time, Debian used to put all of the files for each of its releases in an extremely simple layout. So it was a subdirectory just named after the release. You had dist/buzz, and then all of the debs went in there. This was very simple, but it did have a few problems that became obvious over time. It may well have contributed to the confusion that led to Debian never having had a 1.0 release. It looked like 1.0 in the archive. A company shipped a broken development snapshot in the CD, and Debian ended up going, that was bad enough that we're just going to renumber to 1.1 to avoid confusion. But there was a more long-running problem as well. It meant that setting up a new release meant copying all the files around to different places in the archive. And even with strategies like hard links, this was a huge problem for mirrors because they had to do lots of redownloading. And it was a problem for Debian itself because it had to serve all that data back to the whole network. So in 2000, after a lot of design work, James Troop rewrote Debian's archive infrastructure to use what were called package pools. All the actual packages lived in a big pool directory tree, and dists just had metadata with references into the pool for all the actual contents, and this worked a lot better. When we set up Ubuntu, James was one of the founding Canonical employees. Oops, sorry. James was one of the founding Canonical employees, so the natural starting point was to reuse Debian's archive maintenance software, which he'd in large part written. We did that for the first couple of years of Ubuntu's life. But then in 2006, Launchpad was mature enough to take over responsibility for the Ubuntu archive. It preserved more or less the same layout, and for the most part, it's remained compatible with Debian's archive layout ever since. That's important because we share tools such as apt. In 2007, Launchpad introduced personal package archives, or PPAs. That meant anyone could easily have their own archives, and these have become a vital part of many workflows. They allow easy testing of changes outside the archive, which can then be copied into Ubuntu proper once they're fully cooked. So with all that in mind, some of you may know that the way we serve the Ubuntu archive, and indeed PPAs today, is really a very simplistic piece of technology. We keep the state of the archive in Launchpad's database and in the librarian, which is our file storage service. But then we also just dump all the files out to a big file system on disk and serve it as static files. It has some advantages. It's simple. It's very easy to mirror the whole thing using rsync. And we all more or less understand the operational properties of serving a whole bunch of static files over HTTP. But it has some obvious disadvantages too. If you want to provide different views of the URL structure here, or if you want to add anything fancy at all, like snapshots, then these are very difficult things to do because you're pretty much stuck with the structure you have on disk, and it's complex and expensive to rearrange that. And this is, in some ways, this is similar to the story that I just told you about package pools, but at the next level up. So this whole situation has been bothering us in the Launchpad team for a while. It's 2023. Nowadays, there really are better ways to serve files than that. So one thing that we've been working on for a little while is a web service called LP Archive that sits in front of the Launchpad database and the librarian in a more normal web servicey sort of way, and dynamically interprets all the URLs of the sort that you'd see in our archives to work out how they'd be translated to the appropriate actual file contents. We've known that this would be a more flexible model for quite a while. For internal infrastructure reasons, we couldn't make a start on it until a couple of years ago, but we're now in a much better situation, and this sort of approach is very viable. So how does all this work in the back end? Launchpad already has to store the history of each package published in Ubuntu. It knows when it was published. It knows when it was removed or superseded by a later version, because that information is valuable and required indeed as part of the publisher's own workflow. The history of Ubuntu is valuable data for all sorts of reasons, so we're not in the habit of deleting it. And this is all stored in the form of history tables in PostgreSQL. With good indexes, we can easily query for which packages were published at any point in time. The main thing we had to add was treating the metadata files in the same way. So each time we generate things like packages or sources files that apt uses to figure out what packages are available, we just store those in a database too. And all we really had to do was expose some internal glue to let us ask for the state of a given path at a given point in time, translate those into just the right DB queries, and then make sure that we had caching rules in place and so on the front end. So taking advantage of all of this extra information that Launchpad already has means that we were able to avoid having to bother with the initial approach of that David outlined of inserting extra fields into the metadata files. We can instead just serve out the metadata files as they existed back then. So our first step was, of course, to have LP Archive serve something that looks very similar to what we have today. But then it was a small step to just let you add an extra optional timestamp segment. And we just pass that to the back end to inform what queries it runs. So we're pleased to announce that this is now available in production as snapshot.ubuntu.com. We deliberately used a URL format that's compatible with snapshot.debian.org so that the same tools can be made to work with both. But with our implementation, you don't have to explicitly look up what snapshots are available before you can query them. You just pick a time of your choice, as long as it's after about February 2023, which is when we started recording the extra metadata you need, and then we'll give you what the archive looked like at that time. There's also similarly snapshot.ppa.launchpadcontent.net that gives you a similar view of any PPA of your choice. The caveat there is that because there are an awful lot of PPAs, to keep our storage size under control, we currently have to garbage collect old files from PPAs much more aggressively than we do from Ubuntu. So only a few PPAs actually have older snapshots available, but it can still be useful for looking at quite recent activity over the last week or so. And if you have access to any private PPAs, then we do tend to keep more complete history for them. So I don't often put code on slides for all sorts of reasons, but this seemed like a good excuse just to show how simple it ends up being. In order to support the timestamp URLs to the front end code, it's pretty much just this. We had to add a little bit of extra code to register the URL format with Flask. And of course, the meat of this is really in the back end that's doing the translation and working out what URLs to return. That is a bit too long to fit in the slide, but I promise it only amounts to a few extra constraints on some database queries, and it's not anything fundamentally more complicated than that. So we didn't stop with just having the service in place. Thanks to my colleague, Julian Andres Clode, who's in the front row there. We now have snapshot integration in apt as well. This is available in Ubuntu 23.10, and it's coming soon to 22.04, 20.04, and to 18.04 for pro users who have the ESM infra service enabled. So you just have to set snapshot equals yes in sources.list, and then pass a timestamp to the -snapshot option and then almost all, I'm reliably informed that almost all apt commands will then make use of the snapshot. By default, the app cache uses the normal archive, but you can request the snapshot and use commands with it. So this example has shows using, installing the version of Whois from July rather than the one that Mantic released with. So in practice, of course, if you try to use this to roll back just a few packages in your system to an earlier state, you'll have to do some more things to deal with mismatching dependencies over time. So this may just be one building block, of course, but there are all sorts of more advanced capabilities that this unlocks. Ye and Koshy are going to tell us a bit more about those later, but even just within Ubuntu, for example, if you're an Ubuntu developer trying to figure out what went wrong with a particular archive, you no longer have to go crawling around Launchpad to track down all the package files manually. You just install a test system from the exact snapshot you want, upgrade to the next thing you want, and you're good. If you're the Azure folks here and you want to ensure that your customers can have their VMs and containers only be rolled forward to a newer set of updates once those have been validated, you just pin everything to a snapshot and roll it forward gradually over time. So this is just a very simple demo. Give me a moment while I work out how to get it to go. And see if I can maximize it there. So I've pre-created a LexD image here. I don't think I can get it to full screen, sorry. I've pre-created a LexD image here using Distro Builder in such a way that it's pinned to a snapshot of 2204's updates from the start of July. So I'm just launching a container from it now. And you can see once it gets that far, is it paused? Sorry. That would help, wouldn't it? Thank you. You can see that it's set up to only fetch. So it's set up to only fetch packages from that snapshot. So if I ask it to update, it's not going to do anything because the snapshot is, of course, immutable. If I edit my sources list, roll everything forward by a month to the start of August. In this case, I'm just using the snapshot URL directly rather than using the full apt integration. Then I now get whatever updates were available in the archive at that time. Sorry, I was preparing this demo over the hotel network, which, as people who have been staying here know, is not always the absolute fastest. But you can see that there are a whole bunch of updates to the base operating system, which it's perfectly happy to install, going back in time. So this is all just as if I'd done the upgrade operation at the start of August. Maybe you're debugging a user system where that's the last time that they upgraded, and you need to simulate that. So at this point, once this finishes, I can do whatever I like, and everything that touches the archive will be frozen in time, just as if I'd been doing all of this 3 months ago. So I can install Git here. I'll get the version that was current then. Once again, you need to slightly wait for my 8-year-old laptop to get around to doing it all. But if I now change sources list again to roll forward 1 more month, then you see some more updates to the base OS, but also the packages that I just installed. So this is exactly as if I'd got in my time machine and set all the dials forward by a month. So this was all coming from, while this is a recorded demo, it's all coming from the live site. It's available to the general public. You can do whatever you want with it. Excuse me, that's gone out of demo mode, so I'll have to fix it up in a moment. But there are a few more things that we have left to do here. Is Mark trying to ask a question?
Yeah, just curious. So how do you deal with metadata signatures?
So we deal with metadata signatures because we're saving the signed metadata files in the first place. So we just serve them straight back out to you.
So you're not generating a new metadata for that snapshot. You're finding the closest relevant snapshot, the one just before the time, and essentially serving out something that's pre-cached with its signature.
Precisely so,
Thanks.
yes. Okay. So there are a few more things that we do still need to do, of course. Now I have to be a little bit careful because I'm effectively promising things for those in my team who will still be around, but never mind that. I'm sure they will be just fine. So we do have to figure out some details of the integration of this with ESM. The updates that we publish to pro users are generated by way of a private PPA. So in principle, it shouldn't be terribly difficult to make those work as well. There are a couple of slightly awkward details there. ESM uses a different authentication and authorization system, so we have to get all the glue for that in place. And it also modifies the metadata files and re-signs them. So we're going to have to work out how to glue all of that back into Launchpad. We don't think it's terribly difficult, but it does need a little bit more design work before we can make that work. At the moment, it only implements the absolute bare minimum needed to make apt work. So if you try to browse to the service using a web browser, you don't get directory listings, you don't get some kind of sense of what snapshots are available and so on. So we need to do a bit more back-end work to make that work. But in the long term, we think that this design is a more sustainable one. It's more, it's friendlier to cloud deployments on our side. It's much more flexible. There are a lot of advantages to having this system. And in the long term, I don't think there's any real reason that this couldn't take over publishing of the standard PPA service, and perhaps even of the primary Ubuntu archive, what's on archive.ubuntu.com. All we need to do is make sure that we're not breaking the mirror network along the way, but we're pretty optimistic that this can be the future of how we deploy the Ubuntu archive. Question at the back there?
You've got ESM integration, of course, and you've got ESM integration and, of course, PPAs. The next logical question is Ubuntu Cloud Archive.
Right,
so
absolutely.
Anybody
yes.
that's deployed a cloud and has a server come out of service or wants to scale out without fully upgrading to current is going to have kind of a gap there. And then once you open that door, it's charms and snaps, which don't have snapshots yet either.
Well, there's some slightly different stories within the Snap Store for snapshots. So that's not my circus, but but it definitely has some facilities along those lines. William, do you want to cover that?
This is very similar to the Snap Store cohort mechanism, which can be it's effectively archived snapshots in a slightly different shape. We may well want to look at unifying user experience across that now that we have it for more than just the Snap Store. But yeah, the functionality is fundamentally there. We just probably need to tie it together a bit better.
We need to be able to associate a point in time from the web archives to what the snaps were at that point.
Exactly, yeah.
Yeah. So regarding the cloud archive, that has some of the same concerns that the ESM archives do, not by way of, so authentication is not so much of a problem there, but but I believe that it regenerates metadata in a similar sort of way. So you're absolutely right. It's got a similar thing, but the cloud archive is also ultimately backed by PPAs in Launchpad. So gluing all of this back in is not going to be too difficult. All right, so with that, I'm going to pass over to, I believe, Ye to talk about the Azure guest patching service.
Yes.
So I think I lost the presumption. Okay, well, you may not get speaker notes, sorry.
Okay, hello, everybody. My name is Ye Wang. I'm from Azure Kubernetes Service from Microsoft. I'm very happy to be here to talk about how does AKS do with these Ubuntu snapshot. And first of all, what is AKS? So Azure Kubernetes Service offers the quickest way to start developing and deploying cloud-native apps in Azure data centers or at edge with building code-to-cloud pipeline and guardrails. As a hosted Kubernetes service, Azure handles critical tasks like health monitoring and maintenance customer only manage and maintain their agent nodes. And, sorry. As a part of the maintenance, the AKS offers a fully managed security patching service, which allow customers to control the time and cadence to patch their agent nodes. And then with integrating with the Ubuntu snapshot, we're able to provide the customers with a validated and a consistent snapshot to patch to their nodes instead of using unattended upgrade to always upgrading to the latest packages. And here is what we do previously. And as you can see, we have AKS clusters in all different regions. And then all of them, we previously leveraging the Ubuntu unattended upgrade to be patching the nodes, which is pulling security packages directly from the public repo, which means at a time of patching, they're always getting the latest, which is never validated. So that's exactly what David has shared before. With some rare cases, certain serious events happens, and then that will be render their cluster unusable, which is the node that totally not bootable. And some other weird things can happen, mainly because these unattended upgrade was always pulling the latest and always pulling the latest in all regions without any validation. So for solving this, we have been doing a system which is we can pre-validate a snapshot, which is before we push into the customers. So as you can see, we have built a validation pipeline, which is we can pick snapshot from the snapshot repo, and then we first validate that that snapshot, which is working with our AKS system completely with our end-to-end tests. And then when everything is fine, we will be publishing that specific timestamp to the first staging region. And then we will be following our SDP practices, which David has shared previously. We're moving that timestamp from region to regions with our secure deployment practices. And then with our meanwhile, our security patching services will be pulling that validated timestamp from that given region, and then to retrieve that snapshot from the snapshot repo, and then patching that that snapshot to the clusters in that given region. So that means each region of the clusters will only receive the snapshot which has been fully validated in the previous regions, and that has been published into that current region. So if anything bad happens, like for example, we failed our validation, and then we validated this is like say something like what we happened before, and then we will be just to inform. We have a dedicated channel to inform Canonical, say, hey, we just find out another issue, and then like we need to resolve this. And then this is a way we can resolve issues proactively rather than we detect everything was out in production. So, and also like same thing happens like when if we are going halfway through and then we detect something like say we just missed previously, we can stop right there, and then all the following regions won't receive that rogue snapshot. And then so we will minimize that impact to all the production regions. So I have prepared a small demo. Oh, there we go. For how this works. So I created a demo AKS cluster. And then first, when I get the node of that cluster, I currently have 2 nodes, and then they're on the 2 slightly different versions of the kernel. And they're both on 5.15, and then one is 10.51 and the other one is 10.41. And then when I hop on to the second node, as you can see, when I look at the sources of the list, and then all of them are currently pointing to the original Azure archive, the Ubuntu.com, which is going to be pulling the latest packages. And then what we really do is, as a managed service, we're just turning on the security patch feature, and then the customer does not need to do anything. And then after the command is run, we validate it. Okay, so we already enabled the security patch feature, and then after a while, we just wait for like 1 hour or so. And then we will see the node is already patched to 6.2 10.14 kernel version. And then when I hop on to that node again, and then when you look at the source of the list, and this time it has been all patched to the snapshot endpoint with a 10.08 timestamp.
which is that temp is we pre-validated in our validation pipeline and publish that region. And then on the contrary, I create another AKS cluster with the exact same setup. And then this time, instead of using our snapshot services, and then I would just do an apt update and apt upgrade directly on that node. And then after this is run, so when this is all finished, and then you will see, so the latest will patch to the 10.16 version of the kernel, which is, so that is not validated. So that means we're using this way to protect our clusters in production. So without receiving anything we have not validated yet. So that's all for my demo. And then I will pass on to Koshy for talking about Azure Gas patching services.
Thank you. Good afternoon, everyone. My name is Koshy John. I'm from Azure Guest Patching Service, and a few things that I'm going to talk about are what is AZGPS, why did it need snapshots, how can customers get this, and what's next for our service. Right. So closer. So before you think about AZGPS is a component of the Azure Compute Platform. So what is the Azure Compute Platform? The Azure Compute Platform is the fabric through which virtual machine scale sets, Azure container instances, and all are deployed. So when you think about creating a virtual machine, deleting a virtual machine, starting it up, stopping it, all of that goes through my team. Azure Guest Patching Service is a cloud-native and platform-integrated service into the Compute Platform that manages VM guest patching, which is interacting with package managers on machines for Linux and the Windows Update agent on Windows. And then we have image upgrades, which is replacing the operating system disk for the virtual machine or the virtual machine scale set. And we manage other things like the Windows Azure Linux agent, and the Windows agent and extension upgrades. So all of that stuff inside the Compute Platform belongs to my team. So what does cloud native really mean, right? So one of the things that we need to do at Microsoft is ensure that our systems and customer systems are secure by default. If the customer does not proactively do anything, we need to ensure they're secure. And being a cloud native service, we have to ensure that availability comes first across regions, within a region, within concepts like the availability zone and availability set. And we also have to have health awareness at scale because we're talking about millions of virtual machines, right? And safe deployment in a cloud native world is a foundational concept. It is not a nice to have in something as large as Azure. So strict safe deployment with AZGPS, which is similar to what David talked about and what Ye talked about. We ensure that a rollout goes in a series of phases. Each phase has a couple of regions in them. And in the past, we were not able to ensure that the payload that was deployed into various regions on any Linux system was the same. And thanks to the integration with snapshots, we are now able to ensure that the payload that goes through these regions are actually now consistent and tested. So how does a customer get this? It has never been this easy in Azure. And all it takes is a single setting, and it changes everything. You go from having unmanaged unattended upgrades to globally coordinated updates. You go from having limited clarity because you have to go onto a virtual machine to know what's going on, to having fleet clarity at scale because all of this gets surfaced in Azure through APIs, through the Azure Resource Graph, all of which I will show you. And one of the things that you have on unattended upgrades is that you are not secure until you receive a reboot, especially for things like kernel updates. Azure Guest Patching Service ensures that we check your system to see if it's requiring a reboot and ensures that a reboot happens if the customer has allowed us to do it. And for the first time ever, Ubuntu snapshots makes this promise possible on Linux. Right, so when I was talking about that single setting, I'm just going to walk you through the steps that a customer would go through to get this. So if you go to portal.azure.com, this is the web interface for all of Azure services. And when you go there, you'll end up with a dashboard that looks like this. And I'm just going to walk you through creating a virtual machine. So if you go and click on that thing that's highlighted there, you'll get this list. And one of the popular marketplace products, if you can see it, are the Ubuntu images for 2004, 2204. You can go click create on one of them, and you'd end up with a screen that looks like this. You can fill in the details that you need, which is the name of the machine, what region do you want it to be in, what resource group it has to be in, and I'm going to take you straight to the thing that changes everything. So that's the management tab, where we have this option down there called guest OS updates. And this is an optional setting. You can tell us that you want updates to be installed through Azure orchestration. What this means is that it's no longer going to be, all your machines will not be getting updates by themselves whenever. The rollouts for patches across any managed fleet will be happening through Azure's orchestration service. And as a customer, you can also tell us if you want us to reboot your machine. If a reboot is required, you can say, I want to manage my own reboots. You can do that also. And just to be clear, it's optional. You don't have to take this. But if you do, it's very good for your service. And that's it, right? So with just this one setting that VM create, or you can edit the setting later, we take care of safely patching your fleet. And this, with the benefits of this, extends all across Azure. It's globally coordinated and monitored manually. So my team manages these updates and sees what's going on across the world. There's also automated health signal monitoring, which means that in the middle of the night, if something goes wrong, I might get called saying, hey, something's going on, we need to take a look. And we're very happy that we're able to offer region-to-region consistency, especially for something like we have a test region and we run tests that we have more confidence that what's going to happen in any subsequent region at any subsequent point in time is hopefully as close to reality as it was in test, right? So before, you might be thinking, why would I trust Microsoft with something like this? Right? So you don't have to take our word for it. We have experiences where you can go verify what has been happening on your machine. What you see here is a virtual machine view, where one of the options under operations is a section called updates. And all of this, while I'm showing it to you on a UX, it's queryable through our big data service, Azure Resource Graph, and you can also query it via APIs. So what you're seeing here is assessment. What this is a list of the updates that are available on your machine at any given point in time. And you can track this at scale, right? You can, if you have 1,000 machines, you can go and look at, give me a list of all my machines that's missing this one particular update. And you don't have to go into each machine to figure this out, right? So the thing I want to highlight here is the patch orchestration up there is Azure Managed. You can edit this at any time, but this is what this machine is set up with. So when Azure does a rollout of updates across your managed fleet, you would go to the history tab up there, and you'll be able to see all the operations that's happened in the past. What happened last month, what happened in the past 2 weeks, and all of that. And you would end up with a result view that looks like this, that tells you exactly what got installed, what version got installed, the operation ID if you want to look at it further. And it also tells you if a reboot was required and whether we rebooted your machine for that instance. Right? You can query this even further in the Azure Resource Graph. Like I said, it's a big data store for all of Azure. We have a resource in there called patch installation resources. And you can write a query, and this query can be very rich that goes across machines. The operation ID that I showed you in the previous screen is available here. And there's I'm only projecting properties from it. When you open that up, you would see this message. It says, we've successfully managed to patch your virtual machine in a global rollout. And the actual message will, which is not fully visible here, also contains the date to which we patched your machine, right? So what's next for the integration that we have? We are looking at having customer-specified snapshots. We are looking at having those snapshots available to customers on a schedule they specify. We are considering looking at having a system locked to a snapshot. What do I mean by that? Right now, when I go and patch a machine, it's only for the instance of my patching that I snap it to a specific snapshot. So if a customer comes in and does something else later, they are not experiencing the snapshot. And even if something goes wrong when I'm doing stuff, I will not accidentally leave the machine in a state where they're stuck with a snapshot that they might not be aware of. right? We are moving to a model after a bunch, as we finish preview and we go through this, we expect that by default in Azure, all machines that are capable of having this will be on this instead of unmanaged updates, so that our fleet is secure. We have some leftover work that Colin talked about. We have pro-client integration in our service, and we want to make that better for snapshots and ESM updates also. And by the way, the client code that we have for AZGPS Linux is open source, and you can go see it at any point. So in conclusion, Azure will be the first cloud, is the first cloud that has integration with the snapshot service for AKS, AZGPS. And we are very excited by this. We are very happy that Canonical has worked so closely with us for so long to make this a reality for us. We waited many years for this, but we are very happy. Thank you so much. Happy to take questions from anyone here. Any questions? Can somebody pass the mic? Yes.
How are you performing the validations on package updates? Do you have specific tests for specific packages? Are you using canaries from customers?
So how we do it, so that's an excellent question. So yeah, as Ye had pointed out, it depends on the service. Ye, for example, is taking the specific snapshot and running through a series of tests on a plain vanilla image, right? And while it might not catch everything, that's part of the reason why we have a safe deployment phasing, right? So when it's very difficult for us to always have a representative environment for all customers, because every customer is running with a different configuration. It's very heterogeneous. What we end up with is, when we go through these phases, if there's a representative environment in any of these phases, we will be able to detect that, right? And we also have groupings where a given customer's availability set, if we see that something is happening in their specific environment, that's something we can flag to them also, right? It is a very difficult thing to ensure that the first environment that you have is representative of everything everywhere, and that's why we have phases. Otherwise, it would have just been test and then prod and TAU.
Yeah. To answer that question, the validations of the packages is very complicated because, as David mentioned, the problem is not always, almost always not within one package. Is a specific order of the updates happening, and then specific tasks happened with some packages in conjunction with some other features that the customers having in their node is causing the problem. So it's always for us to do our best effort to catch most of the problems with our end-to-end tests, which is usually just starting with creating one or more AKS clusters, and then to pre-apply our predefined scenarios where we're making sure certain features is working with that cluster. And then with validating the snapshot, we're just before starting validating our scenarios, we're applying that specific snapshot patches to that cluster, and then running over all series of scenarios to be making sure everything is working. But again, it's not possible to catch all possible cases because, you know, a lot of times it's a certain series of actions is triggering a specific error. So then we are just leveraging the safe deployment practices to be pause that if we detect that in production or some customers raising that issue, so we can just stop that deployment and then just engage with Canonical to resolving certain issues as fast as possible.
So another follow-on question, what is the delay? There is a queue of questions, but I don't want to overload on the first. And the delay for the median machine, how long? What is the delay? Are we talking weeks, days, minutes?
So for us, we are planning for like the delay to up to like 2 or 3 days, and then this is totally can be delayed up to a week if some issues is detected, because it's
definitely taking more than a week to resolve and like either rollback or doing a fix forward to happen within a week. But usually the delay should be within 2-3 days.
Who had a question? All right.
Hi, thank you. Great talk. So you mentioned that one of the future work is to allow clients to specify some, like they prefer snapshot. What if there is a vulnerability, like there was a later security patch? How do you plan to deal with that?
So one of the things that we have in AZGPS is we offer a range of options. There are customers who are sitting on unattended upgrades. They just use what I just described here. The other thing that we offer customers is the ability today to go very granular in what they want to do. AZGPS allows the customer to specify that they want specific packages installed, that they want to exclude specific packages, that they want certain classifications of packages to install. Like, there are certain customers that do that. Some Fortune 500 companies want to do that. They want that level of control. For those customers, they take the responsibility for their managed rollout because they have dedicated employees who are responsible for managing their machines and their environments. So they would have their own test environments, they would have their own prod environments, and the snapshot and allowing them to use this is just a mechanism to fulfill their scenarios in the way they want to fulfill it. Thank you. Are there other questions? Right.
This was maybe for Colin. You mentioned apps now has the option, and that's one way to manage the date. And then you were showing in your demo where you changed the configuration of the repository set. Is there like an add app repository command that allows you to just manipulate that date, or is that just, you know, scripted up?
Possibly more for Julian than for me.
Oh, okay.
I don't believe that app repository yet has that. Part of the reason I took that particular approach just for the sake of a demo was that it's a little easier to do rolling forward if you're taking that approach, because the apt integration is you have a snapshot as an additional source. So it was easier to start the demo by pointing it at a very particular point in time several months ago and then rolling forward from there. But Julian, do you have anything you want to add?
Basically the snapshot option allows you to specify a snapshot if you have this snapshot integration enabled that we saw earlier. That, of course, if you start, as Colin did, with an earlier snapshot, then you don't have the apt with the snapshot feature yet, so that's a bit not going to work. But now I lost my train of thought. But if you have the snapshot option, it basically just adds the snapshots as a second source, essentially, and then it just shadows the standard sources so that they don't get used in a cache file.
I think also the app snapshot integration is probably fair to say it's very, very new. So I don't know how much user feedback you've had on it yet, but I'm going to guess not much. So I wouldn't be surprised if we saw this evolve a bit as we start seeing people use it in anger and start, you know, coming up with things we haven't thought of yet.
Are packages in proposed included in the snapshot?
Yes.
Yeah. And how is the snapshotting thing going to work with mirrors?
So we've been talking a bit. There are interesting questions around mirrors. At present, there's just one central snapshot service, which means it doesn't really work with mirrors. One thing that we've talked about is some way to provide the best of both worlds. So it is genuinely useful to be able to provide something like an air-gapped or in region version of the snapshot service. But at present, it's implemented by calling back to Launchpad, so that kind of has to be central. One thing we've been chatting about, and this is still very much at the concept stage, is replicating a small subset of Launchpad's database, or a representation of it, in a form that can be shipped off to an air-gapped version of the snapshot service. It all seems plausible enough, but we haven't tried to actually put that into action yet. I think that will likely be the direction as we move forward, because having this sort of mode is useful enough that it's worth pushing it forward. Now, in terms of the sort of public mirror network, so the sorts of things that you see on, I don't know, au.archive.ubuntu.com or something like that. Lots of those mirrors are very generic. They work with many different Linux distributions or other sources of software. And generally speaking, they've got pretty low tolerance for installing random pieces of bespoke software on their mirrors. They're much more likely to stick with an rsync endpoint. So we may have to work out a way to publish a version of this that can, if we want to take over the Ubuntu primary archive with this system, then we would need to work out a way to make it rsync friendly, whether that be just publish an old school static file system just for rsync or something cleverer, not sure yet.
Okay, thanks.
This is more a question for the Azure folks, and to extend Seth's question. Because of the delay of 2-3 days to validate an update, it might be that the security team release a regression fix on top of what you just published. Is there an exception for regressions? Are you still going to validate the regressions that have this kind of delays, or how do you plan to handle regression updates?
That's a very, very good question. So like we have a very lengthy and discussion over this. It's always going to be a compromise between your stability of your production environment versus security. So you cannot get both. In general, like say, if you're just value your security patches more valuable, your production environment will more suspect to these type of outages. So it's, first of all, it's always a compromise. And then secondly, we have in mind to develop a hotfix system in place for certain really, really high CVEs, which is we could be pulling off a one-off hotfix for that particular patch. We can validate a specific snapshot containing that CVE fix, and then we just speed up that publication. Like say, we can just validate it, still going through the same validation, but we can pushing the specific timestamp to be patched to the regions clusters much faster than usually SCP as a one-off hotfix. And that's going to be serving some like a really, really high CVEs, which is we must fix as soon as possible. But I think it is always going to be a case-by-case evaluation, still going to be a compromise. Say, is this CVE big enough for you to really compromise your stabilities of your production server? And then usually, like when we're talking about our production, really enterprise customers, they doesn't care that much for that specific, even for really, really high CVEs. Their production stability ranks way higher than their security patching vulnerabilities for small chances. And then even like say, even they, for some circumstances, like for example, like a Walmart might be thinking during Thanksgiving weekend, even I know I have a high CVE hole there, I'm not going to be touching my my production server for any reason, because like say, if any disturbance in that server in a very tiny fraction, that probably means like say they're losing millions. So so that's always going to be a case-by-case scenario evaluation.
So there's something about AZGPS is that internal first-party services are required to use us. We have security teams evaluating all these things, and we try to provide third-party customers the same kind of experience that we offer first-party customers. We have an ability to do emergency patching. So if we realize that there is something that's severely vulnerable out there, and with Canonical's help, having us notified, we will be able to roll out patches at a much faster cadence. And as I was talking about in the previous question, customers have the choice to do what they want. They can align, they can choose to schedule patches. Customers who have no tolerance for failures can patch it 90 days later. We have options for everyone. Thank you. Any more questions? No? David, any final words? No. You're out of time. Thank you. Yeah, you're good. There is one more thing. If you want to try out any of this, Azure offers free virtual machine resources that you can try any of this out for a whole year. Thank you.